We talked about type 1 compensator, which is nothing but dominant pole or integral compensation, where we push the LC poles out of your UGB by introducing an integrator in your loop and keeping the bandwidth very low or the integral gain is very low. So, this is only suitable for slow system. The example was your battery charger, so battery is charged the constant current. So, load is not variable. Some of the chargers these days they require fast loop. The reason is sometimes your charger shares the system load with the battery current. So, let us say you are charging the battery same times your system requires all of a sudden higher current and your charger is plugged in. So, your battery's current may not be enough, let us say battery is depleted, then it will draw the current from the charger itself. And another advantage of doing that, even let us say your battery is fully charged and when your charger is plugged in, instead of draining the battery, you would like to draw the current directly from the charger. So, your battery charge will remain, it will not deplete actually. So, that is the advantage. So, but if you talk about the old systems, then it was good enough, the slow loop. With a constant current. Okay. Then your LED lights again requires constant current. Okay. So, when you turn on, it will just draw the fixed current, turn off, then the current will go to 0. So, there is no fast changing load, so it is good enough for that. So, but most of our system, let us say your SOCs or your processors, their load is variable actually. So, depending upon how much activities are going on, your load may vary a lot, or all of a sudden your one part of the system is turned on, then it will start drawing a huge current. So, let us say example of your phone, I mean your let us say watching some pictures or videos, all of a sudden you start getting a call. Okay. So, the moment you start getting the call, your RF transceiver will start drawing higher current and then your load will change. So, in that case the slow loop is not enough and you want your power supply to respond faster, otherwise your voltage will drop and it may go below your regulation level and it may even shut down your system. So, you do not want that to happen. So, what do we need to do in that case? So, we need to increase the UGB, means the LC pole will come inside UGB. Okay. So, then what we can do?
We can add 0.
You can add 0 to cancel those poles and boost your phase around your UGB, so that you get enough phase margin, just like you did in the case of LDO. But in the LDO you had a real poles and 2 poles you were considering, one was at the output of first stage and the output of second stage. So, it was more like a 2-stage op-amp kind of thing. But how many poles we have here? So, integrator by default we need, okay, because we need a very high DC gain. So, other than integrator we have 2 more poles, so we have 3 poles here. Okay. So, which means we have to introduce at least how many zeros?
2 0.
2 zeros, because within UGB we can have only 1 pole. So, 2 pole we have to cancel. So, the next one is type 2. By the way, what do you understand by this type when I say type 1, type 2? So, there is a difference between type 2 or type 1, type 3 system and when you talk about compensator. When you say type 1, type 2, type 3 system, then you define by the number of integrators. Okay. So, just take the case of your PLL. In PLL you have a type 1, type 2 PLL. So, in the type 2 PLL you have 2 integrators, one is coming from your VCO, other is coming from your charge pump. Okay, VCO you require, so by default that is introducing, okay, because that is a your clock generator, and charge pump you require with the loop filter in order to close your loop, because you have to convert those phases into voltage. So, charge pump is required, but if you do not have a charge pump, then what do? You close the loop directly from the VCO output, then it becomes type 1, correct, which means if you close the loop without your charge pump, then you are not comparing the phases, you are only locking the frequency. So, phase is free to go anywhere and it becomes type 1. So, that is the difference between type 1, type 2. If you have a 2 integrator in the loop, nothing else, how many zeros you require? 1 0. If you have a 3 integrators, how many zeros you require? 2. So, when I say type 2 compensation, which means what you require to compensate a type 2 system, and type 2 system can be compensated with only 1 0. Okay. So, that means type 2, when I say type 2 compensation, that means the system has only 1 0, that is it. And this is also called PI, stands for, so P stands for proportional, and I stands for integral. Okay. So, integral we already know, integral is nothing but Ki over S. Okay. Proportional is, it should be a proportional of that, means it is a constant term. So, I can call it Kp, there is no frequency term here. So, if I want to write H of comp, I will say 2 here, which means type 2 compensator. Okay. Kp plus Ki over S. Okay, and what is this? This is nothing but type 1. This type 1 compensator. Huh? So, all you did in the type 1 compensator, you added proportional term, which is Kp, or I will call it H comp 1. I can write it S Kps plus Ki, and it can be written as Ki over S 1 plus Kp over Ki S, which can be simplified as Ki over S into 1 plus S over omega z. So what is omega z here?
K by K.
Ki by Kp. So this has one integrator and or one pole at origin and one 0. So if I need to do the loop gain or Bode plot, not the loop gain but just a compensator. So H com 2s magnitude, how will it look like?
Straight line
Straight line
then flat.
and then flat. What
Minus
do you,
20 degree.
okay. So this is and then, so if let us say this is omega z, what would happen? Flat. Your integrator will get cancelled out. What will be this?
KP.
Okay. So DC gain is infinite and you have the gain after this 0 appears will become Kp, and this Kp can be changed by moving your proportional term and that will move your 0. So the 0 at the lower frequency, this Kp will keep shifting up. As you keep increasing the 0 frequency, this gain will reduce. So now you can adjust the gain by simply moving that 0 or moving your proportional term, that is it. And if I do not have this 0, then what would happen? This will continue,
Becomes like a
okay, and this is nothing but your
K.
type 1. Okay, let me change the color so that let's make it red. And this will be what?
That will be K.
Ki. Okay, and this guy is, where is the 0?
K by
Ki
K.
by Kp, and this is type 2. So how can we implement this? So you require integrator for sure. What extra term I need to add in the integrator to get this? In parallel or in series?
Series.
So let's take the case of GM first. Plus minus this is your V in, and this is your, so I'll call it RP, I'll call it KI, sorry CI, okay. And if this is GM, what is the transfer function?
GM into RP plus 1 by
V out by V in S equal to, so your GM into RP plus 1 over,
1 by SC.
okay. So this becomes So what is Kp?
GMR.
Gm?
GMR.
GMRP. And what is Ki?
GM by C.
Gm by Ci. So if I want to change the Kp, what should I change? Ci, Gm or Rp?
Better change the RP because K.
Yeah, because you don't want to disturb your Ki. Once you fix the Ki, you just change the Rp to get the different proportional gain. Okay. And if I want to find the 0, then omega is equal to Ki over
K by K.
Gm by this
GM will get cancelled.
Gm by
GM by GM into say denominator.
sorry Gm by Ci into
Into 1 by GMR.
GMRP. Gm cancels out, so you get 1 over Rp Ci, which means Gm will have no effect on 0. 0 will remain same. So in this, if you change the Gm, the 0 will not change, but your gain will change. So that may not help much in that case, or it will not help at all actually. So that is why when you want to change the proportional gain, you should change your Rp, so that your 0 will move and Ki will remain same, so you can get different gain. Okay. So if I move the 0 at higher frequency, your gain will shift here. So it will basically it will follow your integral curve, and but simply the point will change. But if you change the Gm, then what will happen? Your integral curve will also change. It will keep shift down or up depending upon whether you increase or decrease. Okay, and your 0 will remain at the same point. But we want to independently change the proportional term, so that you can only achieve by changing the R. And moreover, we want to have this 0 to appear before your resonance happens, otherwise you will not get any benefit of that. So you can place this 0 according to your Rp.